Dear students, in this video we are going to discuss about Beer-Lambert's law. Before seeing to the Beer-Lambert's law, we must be aware of what is Lambert's law. So Beer-Lambert's law is nothing but it is the combination of two laws. So first one is Lambert's law. What is the Lambert's law? So Lambert's law is nothing but it states that the decrease in intensity of the incident radiation is directly proportional to the thickness of the absorbing medium, thickness of the cell. Okay, if you take a system and this contains sample, and if I am passing a light, and this light after passing this sample, its intensity may be decreased. Okay, suppose the intensity may be assumed that it is 100% intensity, the incident light. It is known as incident light. If this incident light has the 100% intensity, then the outcoming light may be having 90% intensity or 50% intensity or 25% intensity. So it is because of the thickness. Lambert states that it is because of thickness. Suppose if you take the thickness of the sample cell may be in this manner. If it may be 1 centimeter, but it may be 2.5 centimeter. Okay, when this incident light is passed, then the 100% intensity will be decreased, might be 50% or less than the above case. Okay, this one is known as Lambert's law. Therefore, the decrease in intensity of the incident radiation, is directly proportional to the length of the sample cell or thickness of the sample cell, okay, or thickness of the container. Then what is Beer's law or Beer-Lambert's law? Later, after the Lambert's, Beer law came and it states that the decrease in intensity of the incident radiation is not only because of the thickness of the medium or thickness of the cell, but concentration of the sample. Okay, so if you have the intensity, 100% intensity of the incident radiation, and assumed to be this is 1 centimeter, then it may be decreasing about 75%. Suppose the container is very much large, then it may be decreased up to 50%. Suppose I am going to fix the thickness of the medium is 1 centimeter, it may be observed by 75% decrease from 100%. But if the concentration of this medium is maybe it may be 1% and this may be 10%, then we can expect the decrease about less than 75. Okay, but provided that the same 1 centimeter thickness. Okay, suppose I am going to increase both, that means here 1 centimeter and this one is 2.5 centimeter, and Now I am going to choose both the conditions, this one as well as this 10% conditions. Okay, if the incident light is passed with 100% intensity, then the thickness of the sample is 2.5 centimeter, and the concentration need to be taken 10% instead of 1%. Then I can expect the decrease in intensity may be less than 50%. So this one is the Beer-Lambert's law. I hope you can correlate these three cases. This is the first case, and this one second case, and this one is third case. Therefore, the Beer-Lambert's law clearly states that the decrease in intensity of the incident radiation is depending on both thickness of the cell as well as concentration of the sample. But Lambert's law states that the decrease in intensity of the incident radiation is because of only the thickness of the cell. So, dear students, I hope you are very much now clear about this Beer-Lambert's law as well as Lambert's law. Thanks for passionable watching. Let us meet in the next video. Thank you.